clock roll. Okay. So till now we were discussing about a conductor, right? About an open surface. For an open surface, how are you going to find the direction of current? Using the right hand thumb rule. So you take the thumb of your right hand, place it in the direction of current and curl the fingers as if you're going to hold it. So the direction in which the fingers are getting curled gives you the direction of the magnetic field, right? Now, what happens if the same conductor is bent in the form of a loop? Then you don't speak about the current flowing upward or downward, rather you speak about the current flowing clockwise or anti-clockwise. Okay. Suppose I take a circular loop where the current is flowing in the anti-clockwise direction. Yeah, where the current is flowing in the anti-clockwise direction. Now, if you observe at the top, the direction of current is tangential in this way. At the bottom, the direction of current is tangential in this way. So at any point, if you draw a tangent at that point in the direction in which the current is moving, that gives you the direction of dl vector at that point. Because we know the dl vector takes the direction of current itself, right? Now, if I take a small element here, then what is the direction of dB vector dependent on? dB vector direction is directly proportional to ideal vector cross r vector. So dl vector is in the leftward direction, which is minus I cap cross. What is r? R is the distance vector from the dl vector to the point where you are calculating the field. So this is going to be r vector. So in this scenario, what is happening is dl vector is minus I cap for the top one, and r vector is minus j cap. So minus of minus is plus. So what is I cap cross j cap? It is going to be k cap. So I cross j is going to be k. Meaning, when a current is revolving in anti-clockwise direction, at the center, the magnetic field is directed towards us. So when you see from this direction, it is towards us. That is what k cap is. Now the question is, this plane is emitting the field lines. Out of the north and the south pole that is present, which pole has a tendency to emit the field lines? It is the north pole. So when current is flowing in the anti-clockwise direction, this is anti-clockwise. This is also anti-clockwise. Join both, you will observe the shape of N, so it acts like a north pole. When you talk about a closed loop, the closed loop carrying current in anti-clockwise direction. That is when you're facing that loop, and if you see that the current is flowing in the anti-clockwise direction, you're actually facing the north pole. Okay. So what happens when you go exactly on the back of the board and observe this? When you see it from the front, it is appearing as if the current is in the anti-clockwise direction. When you go to the back and observe, the current will appear as if the current is moving in the clockwise direction. So if it is clockwise direction, obviously when this is going to emit the field lines, that should be in a position to receive the field lines. For the same loop I'm talking about, from the front and from the back. Okay. Now observe, at this point, what is the direction of current? This is the direction of current. And what is the direction of r vector? From here, I will join it to this point O. This is going to be r vector. So dB vector in this case is going to be directly proportional to ideal vector cross r vector. So what is the direction of dl vector here? I cap cross, what is the direction of r vector? It is minus j cap. If you take the minus sign outside, I cross j is still going to be k. So it is going to be minus k cap, meaning at the center, the magnetic field is going to be into the plane. So into the plane means it is receiving the magnetic field lines. Which pole has a tendency to receive magnetic field lines? It is the south pole. So this arrow mark represents clockwise. This arrow mark represents clockwise. join both, it looks like an S. So it is going to be a south. Okay. So what I'm trying to tell you from here is current carrying loops, right? They act as a magnetic dipole. What do you mean by magnetic dipole? They act as a magnetic dipole. Why did I call it as a magnetic dipole? Because for the same current carrying loop, when you see the conductor from one side, when you face the current in the anti-clockwise direction, it is north pole. When you face the current in the clockwise direction, it is the south pole. So both are occurring for the same loop, hence it's a magnetic dipole.